Hello guys, welcome to my YouTube channel Prakash Coaching Classes. Today we are going to start a new science chapter which is magnetic effects of electric current. So here we in this chapter we are going to study how the electric current affects the magnetic fields lines. First of all, start with magnetic field. What are magnetic fields? The space around a magnet in which a force of attraction and repulsion due to the magnet can be detected. Magnetic field lines have a force, and this we will see. Consider a magnet with north and south bar in the magnetic field. As you can see, the field lines starts from the north pole and ends with the south pole. So these are the magnetic field lines which are virtually detected. This can be physically felt with the help of an iron bar. With an experiment, we can see that the magnetic field lines do generate and have an effect. Now let's try to understand the properties of a magnetic field. Below are some of the properties which are important. I have mentioned here. First, it is directed from the north pole and to the south pole outside the magnet. As you can see, magnetic field lines start from the north pole and end towards south pole outside the magnet. It is a closed and continuous curve. As you can see, starting with the north pole and with the south pole, and inside the magnet it travels from south pole to the north pole. So in this sense it has a closed loop. Third, magnetic field lines is strong near the poles and near the middle of the magnet it is weak. As you can see, the magnetic field lines mostly crowded near the poles. Here at the same point we have two lines. Here from north pole lines, the magnetic field lines are originating, and here the south pole they are terminating. So as you can see that the magnetic field lines are majorly crowded at the poles. So because of which they are at the poles, the magnetic field is very strong. However, in the towards the middle of the magnet there are very few lines, so the magnetic field effect is reduced in the middle of the poles. Fourth, it never intersect each other. Two magnetic field lines never intersect with each other. Why? Because if the magnetic field lines intersect with each other, that means that the two lines have at one point they have two directions, the magnetic field, which is not possible. Next topic, magnetic field due to the current carrying straight conductor. Now let's see, we have a circuit diagram in which we have battery, ammeter, variable resistance and a cardboard. Q is the cardboard and a key. As and when we close the key, current starts flowing from the battery and flows in the anti-clockwise direction. So current flows through this X and Y as downwards. Now when we keep the iron fillings on the cardboard, as and when the current starts flowing, it rearranges itself and in the clockwise direction. So this suggests that as and when the electricity is passed through the circuit, the current carrying conductor it generates magnetic field. This is a very important conclusion from the experiment, that a current carrying conductor can generate the magnetic field. Now this magnetic field has certain properties. As you can see, the magnetic field, electricity is flowing in the straight direction, while the magnetic field is produced in the circular direction. Basically it is a concentric circles. So there exists a magnetic field lines around straight current carrying conductor and in the form of the concentric circles, concentric circular field lines with the conductor at the center. The conductor is at the center, and this experiment shows that a current carrying conductor can produce magnetic field. We will see in the chapter ahead that the moving magnetic field can also generate the electricity. Means it is both a vice versa process. With this, there is one more thing which needs to be answered, that when the current is flowing in a specific direction, the direction of the magnetic field lines in a specific direction. If the direction of the current is reversed, the magnetic field lines direction will also get reversed. So here this comes an important rule, which is a right hand thumb rule. Imagine the straight conductor in your right hand such that the thumb points towards the direction of the current. The direction of the curling fingers of the right hand gives the direction of the magnetic field lines. I am going to explain you. See, this is your right hand. As let's say the direction of the current is in the downward direction. Now, in the direction in which my fingers are curling is the direction of the magnetic field. As you can see in this example, direction of the current is in the downward direction, and the magnetic field lines is in the anti-clockwise direction. The direction is upwards, then the magnetic field lines also get reversed. With this, we are coming to thank you for watching this video. Do like, subscribe and share the videos, and share your reviews in the comment section.